The brightness of stars depends on their distance and the amount of light they emit. Light spreads out as it moves away from the source, causing closer stars to appear brighter than those farther away. The luminosity of an object is the total power, the total energy emitted per unit time of the object. Luminosity refers to the amount of energy emitted by an object as electromagnetic radiation. Luminosity is measured in watts W and represented by L. The sun's luminosity is about 3.9 times 10 to the power 26 watt. Radiant flux intensity is the energy emitted by a star. The illuminated area increases as the light moves away. Energy is spread over the surface area of a sphere for d2. Luminosity L represents the total energy emitted per second. Energy passing through the unit area per second is L for d2. Radiant flux intensity F is given by F equals L for d2, where L is radiant power and d is distance. The unit of F is Wm to watts per square meter. The inverse square law states that F decreases as distance d increases, following F equals L for d2. Radiant flux intensity is the radiant power per unit area passing normally through unit area. Astronomers measure distances to stars and galaxies. Galaxies are vast collections of stars held by gravity. They appear as faint specks or can't be seen. A standard candle is a class of stellar object which has a known luminosity and whose distance can be determined by calculation using its radiant flux intensity, apparent brightness, and luminosity. The distance can be measured using observed brightness, F, and actual luminosity, Lec. Determining luminosity is challenging, but Cepheid variables, a type of stars with predictable brightness changes, can help overcome this problem. Cepheid variable stars have a varying radius, which leads to changes in temperature and luminosity. Henrietta Swan Leavitt discovered their correlation between period and luminosity. By measuring the period of brightness variation, the luminosity can be estimated, allowing for distance calculation based on observed brightness. Cepheid variables are pulsating stars used as distance indicators in astronomy. Earth-bound telescopes can measure distances to Cepheid variables up to 13 million light-years. Space-bound telescopes can measure distances to Cepheid variables even further. Example, a Cepheid variable in the Virgo cluster was found to be 56 million light-years away. A light-year is the distance light travels in 1 year, approximately 9.46 times 10 to the power 15 meters. Other standard candles. The Cepheid variable method does not work for galaxies that are a very long distance from Earth. Other standard candles, like the supernovae, are used for distant galaxies.